So how many people do we have to ask to know the proportion of the whole population that loves candidate X? This is an important question because of the cost of sampling and the desire to have a good estimate. If the results tell candidate X that she is way behind with little time until the election, then maybe she should just save her money and our time. We can begin by manipulating the formula for the sampling distribution for P, the population proportion, just as we did for the mean. Manipulation of the standardizing formula for proportions gives n equals z alpha squared times p times q, all divided by e squared, where e equals p prime minus p. This is the acceptable sampling error for proportions. P prime is the sample proportion we expect to get when we do the actual sampling. In this case, the very object of our search is in the formula, p, and of course q, because q equals 1 minus p. If, in an abundance of caution, we substitute 0.5 for p, we will draw the largest possible sample that will provide the level of confidence specified by z alpha. This is true because all the combinations of two numbers that add to 1, the largest multiple is when each is 0.5. Without any other information concerning the population parameter p, this is the common practice. There is an interesting trade-off between the level of confidence and the sample size that shows up here when considering the cost of sampling. This table shows the appropriate sample size at different levels of confidence and different levels of acceptable error. This table is designed to show the maximum sample size given an assumed p, in this case 0.5 and q of 0.5. The acceptable error, called tolerance in this table, is measured in plus or minus values from the actual proportion. For example, an acceptable error of 5% means that if the sample proportion was found to be 26%, the conclusion would be that the actual population proportion is between 21 and 31%, with a 90% confidence level. Likewise, if the acceptable error was set at plus or minus 2%, then the population proportion would be between 24 and 28%, with a 90% level of confidence, but would require that the sample size be increased from 271 to 1,691. This increase in the required sample size is a large penalty to pay for a decrease in the acceptable error. If we wished a higher level of confidence, we would also require a larger sample size. The table shows that moving from a 90% level of confidence to a 95% level of confidence at a plus or minus 5% tolerance requires changing the sample size from 271 to 384. A very common sample size often seen reported in political surveys is 384. With the survey results, it is frequently stated that the results are good to a plus or minus either 3% or 5% level of what they call accuracy. We know better. This is just a probability they chose.